remains a challenging problem. In our work, we show how MRI visualizations in immersive virtual reality can help medical practitioners to identify blood vessels without the need for a contrast agent. We present the results of a user study and lessons we learned for vasculature exploration in VR.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
We present a suggestive interface for untangling mathematical knots with complicated structures. Our interface can help users deform knots with the right sequence of mathematically legal moves. It allows one to sketch and untangle knots by proposing the right method of moves. If interested, welcome to our presentation.
This work presents a detailed account of an attempt to explain tightly coupled relationships through storytelling and animation in a multi-user, informal learning environment to a public with varying prior knowledge on the domain and identifies lessons for future design. It offers qualitative empirical findings with particular emphasis on how, despite careful design, visitors may walk away with little knowledge about the data and the problem.
Hello, we are presenting deep volumetric ambient occlusion, a novel technique for deep learning-based ambient occlusion in volume rendering. In our talk, we're going to discuss three things. First of all, volume-to-volume learning in general. Second, how you would combine unstructured information with 3D CNNs. And lastly, what you can take away from our work for volume learning in general. See you there.
Hi, everyone. It is a work about graph visualization. With one node link diagram, dragging node can change the layout of the diagram as you like. But how about more diagrams? Dragging nodes can be laborious. Please come to our talk about exemplar-based layout fine-tuning for node link diagrams. We will give you our ideas.
Hello, everyone, and welcome to VizSec 2020. My name is Jörn Kohlhammer. I'm from Fraunhofer IGD, and I'm this year's General Chair of VizSec with some opening remarks. So this is the 17th IEEE Symposium on Visualization for Cybersecurity, and it certainly is a special one. So this is our first virtual VizSec, as it's also the first virtual IEEE Viz. And what we really want to do is bring together researchers and practitioners from academia, government, and industry to address the needs of the cybersecurity community. And of course, we are at IEEE Viz, so it's all about new and insightful visualization and analysis techniques. To get to this point, we each year send out a call for papers and solicit interesting results. And for this, we have full papers where our authors can submit their new technologies, short papers for work in progress. And this year we also introduced a new type of paper, position papers, where you will also see one of those in the third session today. And of course, we have posters, which are part of IEEE Viz posters, and you have probably seen those posters already during the week. This year is a special year. We had a little bit lower submission numbers, but we were able to accept 3 full papers, which is pretty much in line with the acceptance rates of recent years. We also accepted 2 short papers, one, as I said, 1 position papers, and you will also see 3 posters as part of the poster sessions throughout the entire week. At this point, I especially want to thank our supporters, 26 Labs, Sophos, and Data Machines, who generously gave and supported VizSec and IEEE Viz, especially the diversity and inclusivity scholarships. So thank you very much for this. VizSec each year hands out 2 awards. One is the Best Paper Award, which will come up right after the keynote. It's selected by a separate committee each year. And the nice thing about the Best Paper Award is also that we have an invitation for submission to TVCG. So this is a wonderful incentive also for upcoming VizSecs. So please continue to submit to VizSec. Both full and short papers are actually eligible for this award. And later on in the third session, we will also find out who won the Best Poster Award of our 3 posters. I also want to very much thank the organizing committee of this year. We have 2 program co-chairs, Marco Angelini from the University of Rome and Chris Bryant from Arizona State University, who developed the entire program. They took care of the program committee and of all the papers, making the final decisions. So thank you very much for this. We have Rosa Romero Gomez from Uncharted as our publicity chair. Everything went so smoothly. Sean McKenna is our poster chair from Lucid Software Incorporated. And you will also meet him later on in the third session. Everything you see online has been done by Evelyn Sopan, our web chair. Thank you very much for this. And all the Twitter and news and the emails you received by Nicolas Prigent, our publicity chair from LSTI in France. Many thanks also to the steering committee that supported us from the background. And with so much support, it's really easy to be general chair of VizSec. Thank you, everyone. Also, the program committee who did all the hard work reviewing the papers and who made sure that we get the best of the papers accepted, and maybe even those that are not accepted, that those get interesting comments in their work and maybe submit next year and get accepted then. Just a rough program overview at this point. So these are local times. The time zones for you are probably completely different. We'll now have the opening and the keynote, as you know, and the best paper. After a break, we will see our full papers on network analysis and incident response. And there's a new addition this year. We also have practitioner talks. And as I introduced in the first slide, actually, we want to bring together academia and practitioners. And what better way to do this than to give the practitioners some space and some possibility to show us what they are currently doing, what they are thinking about, and maybe help us get ideas for papers of next year. In the third session, we will see short papers and our posters and the Best Poster Award. So stay tuned for these 3 sessions of VizSec this year. Some technical information, I guess by the third day or fourth day actually of this, you already know this, how to get up to the virtual IEEE VIS and find out the more detailed schedule. There's a Discord channel, and at this point, I really would like to encourage you to leave comments on the Discord channel and during the talks, also during the keynote that is coming up, so that we have some good, interesting questions to pose to the presenters. Further information can be found on vizsec.org, which is a website that is separately kept by the VizSec organizing committee. And we also have a Twitter channel where you can find out about this year's VizSec and also about all the VizSecs of next year. So let's come to our first feature point here in the first session, which is the keynote given by Joshua Saxe from Sophos, and it's going to be given live. Josh is chief scientist at Sophos, and he leads the scientific research, which includes machine learning, data visualization, and computing infrastructure. He also wrote the book Malware Data Science, together with Hilary Sanders, which you might have seen. And in the past, he was also leading DARPA-funded cybersecurity research projects for the US government. So he has an excellent overview of the research trends in a changing cybersecurity landscape. And this is exactly what he will talk about, especially where visualization fits into this new cybersecurity landscape. So I'm very much looking forward to this talk, and I give the floor to you, Josh. Thank you for being with us.
Thanks, Jörn. Cool. Okay. Hi, guys. My name is Joshua Saxe. I'm chief scientist at Sophos currently, and my talk today is entitled "Where Visualization Fits in the New Cybersecurity Landscape." Okay, so I'm gonna be giving some hopefully not arrogant opinions about some of the challenges in our field as it stands right now, and some directions that I think we can go to address those challenges. But these opinions are entirely subjective and based on where I stand in particular in terms of what I'm doing currently in our field. So I want to make clear sort of where I'm coming from, and I'm hoping that the opinions I give here are just taken merely as provocations to think about the challenges in our fields. I'm certainly not presenting them as objective truth. So my job right now is I'm chief scientist at Sophos, and Sophos is a fairly large security products and services company. We have technology that runs the gamut in the security product landscape. So we sell firewalls, wireless access points, email security products, web security, device encryption, mobile security software, and server and endpoint security software. We also have an analyst service where organizations can sign up, and we have analysts monitoring their security data streams, hunting for threats, and basically serving as a SOC for hire. So that's something that we do as well. We've got about 500,000 organizations that we defend with our products and services. We protect about 100 million devices, and we've got about 3,500 employees spread all over the world, mostly in Europe, Asia, and the Americas. So as chief scientist, I'm mostly focused on data science, research development, and ultimately productization of our research across this whole portfolio of products and services. So that's the perspective from which I'm coming when I give my opinions about our field. In terms of my background beyond Sophos, I kind of grew up in the hacking scene. As a teenage computer hacker, I went on to work as a R&D and product engineer at a startup focused on honeypots. I did about 8 years' time at think tanks doing government-sponsored research. Most of that work emphasized security data visualization, although there was a significant mathematical modeling and machine learning component to that work. And then for the last 4 years, I've sort of skewed more towards machine learning, although visualization is still a component of the work that I'm involved in at Sophos. If you're interested in the stuff that I say today, please have a look at Hilary Sanders and my book, Malware Data Science. I think many of us here in the audience today would find the book somewhat basic, but it served as a good textbook for undergraduate and graduate classes in security data science. Then on a personal note, there's my daughter Marija, my wife Ksenia, who's an art historian, and our new baby as of last Wednesday, Yasha. So if I'm a little out of it today, it's because I'm dealing with a nocturnal newborn baby who likes to feed all the time. So okay, with that, let's get into the talk. So I want to tell a little bit, a short story about work I've done over the last decade or so that'll lead into the argument of this talk. The first paper I published was actually in VizSec. So I want to say thank you to those who invited me to give this keynote today. It's a real honor, and it's poignant for me to come back, having been a very junior researcher when I first got here. And this paper was on visual malware similarity analysis. And it was the first paper in a line of research that my colleagues and I did under DARPA funding over the course of about 4 years. This visualization was inspired by like bioinformatics visualizations of DNA. So what we did was we ran malware samples in a sandbox. So each one of these text labels represents an individual malware sample. And what you're seeing here, and I'm not going to go into too much detail, is a visual representation of the run of that malware sample in a sandbox, where we did a segmentation on the thousands of system calls that the malware sample made when running in the sandbox. That segmentation was done by using a discrete state Markov model. And then we clustered samples based on these segments of system calls. And you can see variation in these clusters. So this is a cluster of about 15 malware samples. You can see some variation here. You can see a lot of overlaps and similarities because of code sharing in the malware corpus. I also spent a lot of time doing cyber situational awareness work in my time on government-sponsored research projects. This is a Bayesian network visualization of a risk assessment tool that I led the development of on a military-oriented project. I'll talk more about this later, but this represented a second line of research that I've worked on in VizSec. And then the other body of work I've been involved in is in developing lots of different machine learning detection models. So at Sophos, I'll talk more about this later, but we've deployed malware detectors that run on web content, that run on PE binaries, on Android apps, email attachments, that kind of thing. And in thinking about giving this keynote, and kind of going over my past work, both in machine learning and VizSec, I noticed a difference between those two bodies of work. Namely that it's been way easier to get to real world impact, positive impact on organizations seeking to defend themselves from cyber attacks in the machine learning space than it has in the visualization space. So at Sophos, we deployed one machine learning model into our products in 2017. We had 5 deployed in 2018. That shot up to 17 in 2019. And by the end of the year this year, we'll have about 36 machine learning models in circulation, affecting tens of millions of endpoints and thereby users, detecting tens of thousands of attacks per day. And that feels really good to go from a creative idea about how to model malware detection to real world impact on the behalf of real people. And what I noticed is that while I've probably spent about the same amount of time in visualization as I have on machine learning, it's just been much harder to deploy the visualization work. We've deployed some work. I'll talk about this project later, and it has had an impact. But VizSec, I think, is just harder, even though it's no less important than other types of security research, like machine learning, like exploit prevention, like lots of other fields that are adjacent to what we do and are probably familiar to much of this audience. And what I want to focus on today is the question of why impact in VizSec is harder. Why is it harder to get to impact with the tools that we propose in this forum than it is with machine learning based malware detectors or control flow integrity checkers, many of which have made it out into the world of operating system defense, or really good proposals around solving the key distribution problem in cryptography. Why is it harder, and how do we mitigate that hardness, given how important, I think we all know, VizSec actually is to a secure future for computing? Okay, so on the one hand, it seems like it shouldn't be hard to have a really big impact with security data visualization. Data and data science are very much in the zeitgeist of our fields right now. If you walk the trade floor of one of the industry conferences like RSA and Black Hat, it's just totally apparent that the industry has internalized the idea that security is in many ways a search problem over very large data sets, and that we need data science, including data visualization, to solve that problem. The human in the loop, I think more and more, especially in the last few years, is in the security zeitgeist. There's more and more attention being paid to the fact that not only big organizations that can afford SOCs, but also smaller organizations who subcontract out to services like Sophos, CrowdStrike, and others need humans looking at security data feeds and monitoring their networks. I think that is becoming an accepted idea in our field. Data visualization literacy is more prevalent than ever. For those of us who read publications like the Washington Post or the New York Times, I think we've all been, I imagine we're all satisfied to see the academic visualization literature having an impact on data visualization that gets consumed by millions of people, sort of lay people, readers of those publications. I think visual literacy is just improving really rapidly as data journalism becomes a real thing out in the world. And finally, tool ecosystems for implementing data visualizations have just made it so much easier to research, develop, and ultimately operationalize data visualizations, whether it's D3 or Amazon or Azure, which allows to spin up the backing infrastructure for our visualizations. It's just become so much easier than it was when I started out in this field 12 or so years ago to do research development and productization of visualizations. So it feels like it should not be that hard to have an impact. And yet I think most of us can relate to my experience, which is that even when my colleagues and I have developed visualizations that evaluate well in user studies, it's hard to get organizations to adopt our visualizations. Even when I've succeeded at times in productizing data visualizations, sometimes they wind up as just decorations onto autonomous systems that users rarely visit. And users, and I think they're often wise to do this, cling to their existing tools that they know how to use. grep is still a competitor to many of our proposals here, right? So it's often hard to sort of dislodge existing practices, even when our proposals do really well in user studies. So I've got 4 theses here. They're certainly not complete, but which I'd like us to consider in thinking about where we run into issues in reaching real-world impact with our work. First, I think it's very easy and almost inevitable that we underestimate the costs that our proposed visualizations would impose were they to be operationalized. The cost that they would impose on visualizations, on organizations. It's costly to have a human in the loop in security technology in the real world with constrained security budgets and security not a priority for most organizations. Most organizations are focused on optimizing, really all organizations are focused on optimizing a utility function that is not about security. It's about maximizing profits or maximizing social goods or maximizing some other quantity. Second, it's hard to, from where we stand as researchers, somewhat divorced from the field of practice, it's hard to evaluate how and whether organizations will benefit from our proposed visualizations. It's one thing to get users to give a thumbs up to visualizations in a controlled environment in a user study. It's another to convince a CISO or even a CEO that they should invest in a visualization in the context of their actual organization. And it's hard to see that as researchers. But if we want to get to real world impact, we need to optimize, we need to do our best to maximize the possibility that organizations will want to use our visualizations. And just getting the information about about how organizational decision makers will regard our visualizations is hard. Another challenge is that security data visualization intersects with autonomous and machine learning technology. One of the foundational motivations for VizSec is the ability of our visual cortices to do preattentive reasoning about data when presented in a visually elegant format. You know, the human visual system is very good at spotting patterns, outliers, and trends in data, but increasingly so are machine learning algorithms. Machine learning algorithms are a moving target, and it's hard to discern when an autonomous approach that doesn't involve visualization is the right tool for the job in solving a security problem, when we need a hybrid approach between AI and visualization, and when we need a purely visualization-based approach. And finally, security data visualization is just an inherently culturally contingent proposition. Visualization that will work for one organization may not work for others, depending on the priorities of the organization, the expertise they have in-house. And that's just different than shipping a machine learning malware detector, where if that system, where systems like that can generally address the entire population of organizations in the world, you know, assuming that we agree on what constitutes malware. It's just different when it comes to visualization, and that means that our addressable market of organizations when we propose an approach is constrained. And even with all these challenges, I want to make it clear, visualization is absolutely essential for our fields. So I'm posing these challenges in the spirit of wanting to solve them and wanting to maximize our impact. All security decisions are ultimately human decisions, and they're human decisions about data. And visualization is almost always going to be helpful in human decision making when it comes to security. Because security is so subjective, it's subjective what security policies you want in an organization. It's subjective how aggressive how many false positives we're willing to tolerate in an organization it is. Because there's so many subjective policy questions, there's just a huge space of decision making that AI can't replicate and that will always need human-computer interaction and data visualization for. And there's also just the right ecosystem right now for security data visualization. Those are all reasons that I think tweaking the way we design our research programs, the way we conduct our research, and the way we seek to get to impact with our work is important right now. Okay, so just to drill into these theses a bit more before I get to proposed directions forward and solutions. I think that there's a problem in the way we do literature in VizSec. I think that we talk far too little, if at all, about the costs on real-world organizations of implementing our visualizations. And we mainly focus on the benefits of our proposed visualizations. So if you were just to look at the benefits of, say, a hybrid AI VizSec malware detector that involved an AI component and a human in the loop, it's likely that you could show that the benefit of including a human in the loop and including your visualization was greater than autonomous malware detectors that didn't involve a human in the loop component. And many of our papers show that. I've published papers that show that without considering costs. Once you consider the costs in the real world of an organization, say one of Sophos's hundreds of thousands of customer organizations, the picture becomes radically different. Because as soon as you have a human operator that you're proposing spends a significant amount of their time with your visualization, the costs just skyrocket. They go far beyond the cost of purchasing the productized version of your tool, and they go to salary budget. So really, our proposals live up here in the cost landscape. Autonomous solutions that just raise an alert every once in a while when they detect something that seems like it's definitely malware live way down here in the cost landscape. And what this means is that merely achieving some demonstrated benefit in the accuracy section of our papers or the user evaluation section of our papers is insufficient to get organizational decision makers to choose to operationalize our visualizations. Many of our proposals live down here in the benefits continuum. Some of them live up here. But it's important to discuss costs because if we propose a solution that lives over here in the cost landscape, it might get adopted. If it lives over here in the cost landscape, it might not. I think we need to include discussions of costs in our literature. Here's an example where I fell into this trap, I would say. So this is a cyber situational awareness visualization that I developed in a military context. So the model given by this visualization is you have cyber threats that threaten the physical resources of an enterprise. Those resources enable capabilities like video chat, and those capabilities enable missions to be successful, like transiting a ship across the Pacific. And now under the hood, this is a Bayesian network. And if you set the state of, say, a router to compromised, we can propagate probabilities through the network and determine that this mission is highly jeopardized by that compromise. So this is a tool that I proposed for doing forward-looking analysis to identify IT assets that needed special attention, that were too critical and needed some redundancy, and also for doing impact assessment. And people really loved this tool. I showed it to lots of different military decision makers. They wanted it. And it did really well in an evaluation where we asked how quickly can decision makers accomplish tasks with this visualization? What's their qualitative experience of the visualization? Would you choose this visualization over the way you do risk assessment right now, which for many of these users just involves a lot of ad hoc, asking their staff where they felt like the risks were. Bottom line, the tool did really well on the traditional kind of user studies that we do in our fields. But when it came to discussing operationalizing the visualization, it was quickly determined that there was really no future for this tool because actually maintaining a Bayesian network of a large enterprise where you are manually encoding probabilities, maybe with some automation, but with a lot of manual labor, where you're tracking the state of your assets and how they map to capabilities and missions, just would have been far too costly. And the benefit of that, given the costs over simply asking people for their organizational folk wisdom about where risks existed in the enterprise, just wasn't worth the cost. And I think it's important that we capture this when we conduct our research. I definitely didn't capture this. And I think what I came up with on this project was good and probably an intellectual contribution. But ultimately, I think as applied researchers, we're in this game to make impact. And I think at least considering costs and discussing it in our papers is a step in the right direction. So we can get to a state where the tools that we build wind up having a downstream effect on the people we would like to defend. Okay, second thesis. Just knowing the impact that our proposed visualizations might have on organizations, given their cost-benefit trade-offs, is a hard problem. Security is not simply an additive game where you pick the best technologies and lump them together, and then you get a protection score that's the sum of the benefits of your components. It's more like a complex problem like urban planning, where a decision to, say, install light rail in your city is contingent on lots of different factors and involves reasoning about opportunity costs and your existing investments. So studying the impact that a proposed visualization might have on real-world organizations making real-world decisions based on their existing technical ecosystems or where their technical ecosystems are going, I think is really important. I think most of us, definitely me and my work as well, tend to focus on making the light rail system as good as possible. Whereas CISOs, who are the ones who make the decisions about whether or not to use new ideas in security, really focus on the whole picture. And I'm not saying that we don't need to focus on making better light rail systems and optimizing the various parameters that we would like to optimize when it comes to light rail. But I think focusing on this larger picture would lead us to focus on the most important problems in our field and understand whether or not improving light rail is even the issue right now, or whether it's even the issue for the next decade. I think we need to at least begin to think about this picture. And I think that, and I'll talk about what that means in terms of how we conduct our research a little bit later in this talk. Ultimately, what we measure is what we improve. We currently do a good job of measuring accuracy in many of our papers and measuring users. We measure how quickly users learn to use our tools, how well they solve a very well-specified problem with our proposed tools. And we compare that to how they, oftentimes the best papers compare that to how they solve their problems with a baseline technology or their existing tools. I think we need to keep doing that. I also think we need to measure organizations. I think this might involve interviewing CISOs in smaller organizations. It might, that don't have CISOs, it might involve interviewing whoever else makes decisions about security strategy. And I think we need to look at we need to evaluate how our proposed visualizations could impact existing practitioner workflows and also future practitioner workflows based on where workflows are headed in the future. And I think this just by allowing us to measure expected real world impact of our tools, I think will help us get to real world impact in the next sort of generation of security technologies. As I've gone back and done thought experiments around considering how CISOs would think about some of the papers I've published in the past, like this malware clustering technology. This is a useful technology in a very rarefied set of cases in organizations that have large malware analysis operations. So again, this is a malware clustering tool where we run malware samples in a sandbox and then we cluster samples that had similar sandbox runs together. But honestly, most Sophos customers, even large customers, can't afford the opportunity cost of having people look at software binaries on their network using a tool like this, because they have thousands of unpatched vulnerabilities in their infrastructure they need to fix. Perhaps using this tool in isolation, I could demonstrate an empirical benefit to this tool. But once I look at sort of the city view that I showed a few slides ago, it quickly becomes clear that there isn't a place for a visualization like this in most organizations. And I want to maximize my impact as a researcher. I might look at other problems, like the vulnerability patching problem, for example. Okay, third thesis. VizSec intersects with AI in interesting ways that I think raises some opportunities and also raises some challenges. So like I said at the beginning, our ability to do preattentive reasoning on data in our visual field is quite striking, right? So, I mean, all you have to do is just, and I think many of us who had this experience when they got into our field and saw visualizations like this, like all you need to do to notice the preattentive power of our visual systems is to just look at these images and see that we're not doing a linear search over these points in order to detect the anomalies, right? There's parallel processing that goes on, and we're solving the anomaly detection problem in these images in like sublinear time, and that's really impressive. And I think that is a great motivation for security data visualization. A problem that's emerged for this story in the last 8 years is that machine learning has gotten really good at computer vision. Convolutional neural networks can solve narrow pattern recognition problems really well, sometimes better than under the right conditions, better than the human brain. And this just poses a problem for our field. Where is AI appropriate and where is visualization appropriate, and how do we combine the two? You know, my experience at Sophos and shipping data science technologies to our customers is that machine learning is appropriate in all sorts of places. We are using it everywhere, and my team is very busy integrating machine learning into the core decision pipelines of all of our products. We can't work fast enough on this problem. And I'd say this is new. It's new because machine learning tooling has gotten better. It's new because the database substrate on which we build machine learning models has gotten better. And it's also true because the mathematical techniques that we use in machine learning modeling have gotten better. What problems are appropriate for just autonomous machine learning versus require a human in the loop is changing, I think. I think it's really important as researchers that we track those changes so that we target our research as efficiently as possible. It's really important that we become AI researchers in many cases, or at least become conversant in like the modern neural network literature in order to make the right decisions around designing our research programs and executing our research. And of course, the AI trend is part of a larger trend that's just very much in our social zeitgeist right now. This chart is a little hyperbolic, I think, but I think is within an order of magnitude of being correct. This is from PricewaterhouseCoopers and suggests that many areas of work are going to get disrupted by autonomous systems, whether it's looking at medical imagery in the healthcare sector, whether it's making financial decisions, whether it's autonomous vehicles. We're going to see some level of displacement of human in the loop labor with autonomous systems. I think security is no different, and I think it's very important that our field stays aware and that we keep our finger on the pulse of this seismic shift in the tech landscape, particularly because the VizSec VizSec at its heart proposes a human in the loop, right? And we need to know where a human in the loop is actually appropriate. Okay, I'm gonna skip over that slide just in the interest of time. And then finally, security data visualizations are culturally contingent in the way that a control flow integrity checker, in the exploit prevention world is not. I think it's fair to say that all organizations want to detect and prevent buffer overflows. And if we can deploy, say, a control flow integrity checker cheaply enough in terms of performance, we can address almost all organizations in doing that. Security visualization is just different. Organizations are at different levels of visual literacy. Organizations interpret depending on cultural context, they interpret the semiotics of visualizations differently. And I think it's just important that we think about who we're addressing and talk about it in our papers and in our conference presentations. There's a long tail of smaller organizations that are doing very basic IT security. I think from an ethical point of view, I personally am most interested in addressing those organizations, but they're just different than very large security mature organizations that take a risk-based approach to security, like large banks, government agencies, that kind of thing. I think it's important to be explicit in talking about our addressable market when we propose visualizations. I think just being explicit and talking about that and naming that in our literature, I think will lead us to design research programs that address the most important organizations, say hospitals, and the most organizations, say smaller businesses that may not have dedicated IT security analysts, almost definitely do not. Okay, so I've touched on what I think are the important challenges in our fields, and I've touched on some paths forward, and now I want to talk more explicitly about paths forward for security data visualization. And then finally, I'm going to give some examples of, I think, visualization work that does a really good job of addressing the modern opportunity landscape for VizSec. So I think, as is probably totally obvious based on the things I've said thus far, we really need to go further in embracing our role as an applied discipline. And I think what this means is that beyond user studies, we need to start doing organization studies. We need to take organizations very seriously as sociological entities that are solving complex resource allocation problems. And we need to think about how our tools figure into that continuous process of solving a resource allocation problem. Organizations are trying to minimize risk, minimize cost, and maximize some other utility function. And when we propose visualizations, I think it's often appropriate to really dig into that and think about it and assess how impactful our proposed tools can be. I also think it's essential to embrace the technology trends going on in the IT landscape as a whole and in security. Work presented in fora like VizSec tend to get operationalized downstream 3 to 5 to 7 years later. It's important to see where the puck is going, so to speak, and skate in the direction of the puck versus just take a swing at the puck where it is right now. Some of those trends, I think, and I'll talk about these in a minute, are around providing human-in-the-loop security services to small businesses. I think that's an area where our work can have a lot of impact. Machine learning is obviously a trend, and zero trust and remote work are also trends, which I'll talk about in the next few slides. Okay, so I don't want to belabor this, but I think embracing and understanding the real-world resource allocation game that organizations play and addressing this explicitly in our literature, in addition to user studies, I think is really important in pointing our field in the right direction towards maximizing our real-world impact on protecting people. There's a slow-moving but deep and seismic trend happening, which most of us are probably familiar with, towards a new model for how security is done. We're moving from an on-premise world in which the computing assets of organizations are co-located with workers in offices and factories and on-site to a world in which everything is distributed. So even when workers are working on site, much of the computation happening on behalf of that organization is happening in the cloud, in software as a service applications. And increasingly, people are computing from their mobile phones at Starbucks, from their home offices. And so the traditional model in which there's a kind of a firewall perimeter around a trusted network is it's still probably dominant in the world, but it is slowly dying. And by the time many of our proposals have a chance of becoming operationalized and helping people, this world will be like Roman ruins, and we'll really be living in this world, I think. So I think it's very important to come up to speed on the jargon and the trends and the technologies incident to this future world that we're moving into. There's a trend that I'm personally very excited by towards small businesses using expert human analysts to help defend their networks. And the way this is happening is large organizations like Sophos, but also CrowdStrike and many other large security companies providing security services to these small organizations. The way this works is the large company, be it Sophos or CrowdStrike or some other organization, will install a small agent on the customer network that will feed security relevant data up into the cloud, where analysts will have analysts on the security company side will have access to it and hunt for threats. So there are probably a dozen players right now in this market. The market for security analyst services is growing at a 23% compounded annual growth rate, so really quickly. And we at Sophos we see this as a fundamental trend happening in the security industry. We're going from a world in which security companies offer merely security products to a world in which security companies offer security services as well. And what this means is that there's going to be a lot more human in the loop, even for long tail sized organizations. I think this is a huge opportunity for our field because it means that there's going to be a population of potentially visualization literate and definitely subject matter expert users defending a much larger population of organizations, which means that visualization will be more appropriate in more places going forward. I think it's important that we recognize and take advantage of this trend. And then there's the AI trend. And I think I've said what I wanted to say about that. I think embracing AI, keeping up on the literature, understanding where it's appropriate to combine with AI, where we think AI will edge out the need for a visualization. I think those are all really important to maximizing impact. Okay, so finally, I wanted to talk about some visualizations that have been successful. And I think that they can give us a bit of a conceptual heat map for knowing where we can kind of pile on and do additional research that has a higher chance of or has a decent chance of making an impact. One is Google's virus total graph tool. I think this is a great example of a visualization that combines artificial intelligence. It uses artificial intelligence where artificial intelligence is appropriate, and uses visualization where human judgment is appropriate. So I imagine many of you have used this tool. Basically, what it allows you to do is upload data from your network, scan that data with, I think, what's now 80 different antivirus engines, most of which use machine learning, at least as a component of their decisions, and then graph out relationships between components. So there's kind of an overview here, and then details on demand pop up over here. I'm not going to go through a whole walkthrough of how this tool works. You can look it up, I think, and probably see a free demo. The full version is paid, but I think you can find demos online. But what I really like about this tool, and the reason that I think so many people in SOCs use it, is that it brings machine learning to bear in all the right ways of just deciding what artifacts are worthy of inspection. And then when it comes to human judgment and understanding, like, where are these artifacts coming from? When there's a URL, what country is it from? When there's an IP, what ISP is it connected to? It presents all these data in a way that the human can just reason about what's appropriate for a human to reason about. So I think it's a really good example of a combination of AI where appropriate and human intuition where appropriate. And the result is that this is a very widely used tool in the security industry. We in my research group at Sophos designed a visualization to help explain to analysts why we think a binary is malicious when our machine learning malware detector has detected it. So basically what's going on here is we have a machine learning malware detector running on people's endpoints and also scanning files that we see in emails, email attachments, and other contexts. And when we find a file that's suspicious, but maybe not necessarily malicious, we surface it and show users, among other visualizations, this visualization here. This is a kind of decision tree visualization. What we're showing them is that we saw this feature. This is a document. It contains Visual Basic code. Of the files in our training sets, 8 million files that have VBA code are malicious. 400,000 are benign. And we've normalized these counts so that they're 50-50. But basically, you can see that it's a visual representation of the conditional probability the file is malicious based on simply this one feature. But then when we add another feature and the VBA code executes on document open and close, then our conditional probability changes, right? 7 million files in this resulting intersection are bad, 69,000 are good. We keep adding features, and finally we get down to our decision, which is, given all of these conditions in our training set, 7,800 of these files are bad and 3 are good. And this is why we think this file is malicious. So users actually use this visualization to convince themselves that we made the right decision. We also show them ambiguous files where we're not sure they can make their own decision. So this is just an example of interfacing AI with VizSec. ML does most of the work here in surfacing the tiny fraction of files that we think are worthy of inspection, and then visualization helps users run the last mile and decide whether or not suspicious files are actually bad or not. We're seeing lots of visualization in endpoint detection and response products, which I think is exciting because endpoint detection and response products are products that IT security analysts are really living in, spending hours a day looking at. And I think it's just worth looking at the visualizations that folks are looking at there. So I mean, this is just a simple process tree visualization, an overview, and then with details down here. These tools also combine artificial intelligence and expert system logic with visualization to sort of allow autonomous pattern matching algorithms to surface the tiny fraction of phenomena that are suspicious, and then helping humans run the last mile with a visualization. So just another example of, I think, deployment of VizSec that has lots of real world positive human impact, and that runs with the grain of all the themes that I've been talking about in this talk. Okay, so that's what I wanted to say today. In conclusion, say VizSec is inordinately important today. Human judgment is as essential as ever. It's the key ingredient to cybersecurity, and we have the data systems now to allow human judgment to be informed and contextualized by data. I think that's why our field is so important. But to get to impact, we really need to think about cost, organizational decision-making, and we need to introduce those factors into the way we publish our papers and discuss it at conferences like these. Part of getting there will mean embracing artificial intelligence, as I've said, and I think there's a confluence of factors that I've named in this talk that really make this the right time to push and seize the moment. And with that, here are my contact details. If anybody would like to reach out, I'd love feedback or thoughts. And there's my Twitter handle. So thank you very much.
Well, thank you very much, Josh, for a great talk. I really enjoyed it. And maybe I can start with some comments that came up during your talk. Especially many people appreciated the thoughts of you about or a reflection on the value of visual analytics, not only for cybersecurity, but also in a broader sense, since that is something that comes up also in other domains. What is the cost of visualization? And then many people commented on the SimCity metaphor. It was also quite appreciated. But let's start maybe with a first question. So here the question is, in which ways an organization we could engage the organization in conducting organization studies instead of user studies? I mean, there's the question of where do you start? Do you go for the response teams or the researchers? And sometimes it's even difficult to just engage one or two people in the company to really get to them. What is your experience with this?
Yeah, so I think the people to interview would be the people who are solving the resource allocation problem, right? So in my organization at Sophos, it would definitely be our CISO, who he sits in quarterly business review meetings where we look at budgets. He understands the overall priority of Sophos as a business, and then he also understands his need to minimize risks. And so he's keeping all of that in mind when he decides what technologies to pick and how our SOC's workflows should evolve. And so I think so in my organization, it would be that person. I think and that's for sort of like mid-sized to large enterprises. And I think you can get a lot of mileage. I know in my own work, I haven't done this yet, but I could have gotten a lot of mileage in talking to folks like this, because they're sophisticated about the technology and they also sort of bridge the gap between that and the priorities of the business. In smaller organizations, sometimes the people to talk to are the IT contractors. Oftentimes smaller enterprises use contractors to provide their IT services, and they would really be the people to talk to because they actually make those same strategic decisions for their client organizations. I think it depends what demographic you're targeting, but I think it's whoever's solving the resource allocation problem where they're trying to, solve the dual optimization problem of minimizing cost and also minimizing risk.
Thank you. That question was by Marco Angelini, I should say that. There's a question by Fabian Fischer, also thanking you for the great keynote and also the metaphor of SimCity to highlight that security is not simply additive. The question by him is, do you think it's feasible to combine forces with business administration and alike to get more perspectives of benefit costs and other organizational aspects?
Yeah, I think that's an exciting perspective. I think the more, you can go too far in this, right? But I think thinking in terms of the microeconomics of all this is really important. I mean, that's one thing I spent 8 years in the government sector, and then now I'm in the commercial sector, and yeah, I've just learned how much comes down to microeconomics when people make decisions about what to do with respect to our proposed technology. So yeah, the more explicit we can get about that, the better, I think.
Yeah. Okay, thank you. One other question by Robert Goff. We have great tools for user error, time spent performing tasks to measure user benefit. Do you have ideas for practical metrics we can use to measure organizational costs? That's maybe a tough one.
Yeah, well, so that's the path we're embarking on in Sophos over the next couple of years, actually, is as we develop, as I mentioned, we provide IT security analyst services to lots of small businesses. And as we deploy tools to those analysts, yeah, what we're focused on is measuring ultimately the economic benefits of using a proposed tool, which involves looking at, how much time are they spending, using, say, like in a tool, what's the opportunity cost of that versus using other tools, right? Ultimately, does it benefit our customers or not? Like I said in the talk, like you can propose a visualization and show in isolation that provides a benefit, but then there's the opportunity cost question of like, would the time have been better spent elsewhere? And so yeah, I think as soon as you introduce these economic variables into the picture, you can sort of join them up with the tools that you use and user studies, right? And start giving economic outputs, right, and making economic arguments about the benefits of your approach.
Thank you very much. I see there are one or two more questions, but we are running out of time, unfortunately. You gave your email address also in the end of your talk, and maybe you also, I don't know if you're around during the day a little bit.
Yeah,
thank you so much again.
Yeah,
okay.
Thanks a lot. Okay, bye, Jörn.
Hello, everyone. I'm Mark Angelini, and right now I'm very honored to present the Best Paper Award for this year VizSec edition. So, first of all, as Jörn introduced, a Best Paper Award committee was formed, composed by me, by Chris Bryan from Arizona State University, and by Sean McKenna from Lucid Software Incorporated. And the committee worked, as you imagine, on choosing and selecting the best paper. The methodology that was followed this year for electing the best paper initially selected 3 candidates based on reviews and review scores among full paper and short papers. And then from it, each of the committee members read the paper and evaluated them individually based on the following metrics: as the novelty of the idea proposed by the papers, the soundness of the approach presented by each of the contributions, the scientific rigor that was followed in unfolding the idea and results inside the contribution, and finally, by the impact that the idea presented in the papers could have to VizSec and visualization for cybersecurity in the wild. A final discussion meeting for electing the best paper was then conducted after each of the committee members scored the paper individually. And here, for the sake of reproducibility and transparency, I present in anonymized form the results of this evaluation, where clearly are represented the submission and the grade of evaluation, and the scores that ranged from completely excellent to a little bit less excellent to a tiny less excellent. So still all excellent material. And looking at them, looking at these results in visual form that usually we are really good at, we eventually reached a full consensus on what is put here as submission B, that eventually presented the highest level with respect to the other contribution, with respect to pretty much all the evaluation metrics we selected for this year. And even if I would like to be a surprise, but probably many of you already read the program, the winner for this year Best Paper Award is the paper entitled A Visualization Interface to Improve Transparency of Collected Personal Data on the Internet, by Marija Schufrin from Fraunhofer IGD, Stephen Lamarr Reynolds from Fraunhofer IGD, Arjan Kuijper from Fraunhofer IGD and Technische University of Darmstadt, and Jörn Kohlhammer from Fraunhofer IGD. Going briefly and without spoiling too much of the paper, the paper coped with an important and actual problem, that is the protection of personal data with respect to all the platform where a normal person could expose it without being aware of what is exposing of himself. And the idea is unfolded through a very deep related work analysis that highlighted that what was missing and what can be achieved by a work like the one proposed, a well-motivated design of a platform called Transparency VIS that allow to understand to what kind of exposure we have with respect to our personal data on social networks or on big data platforms like Amazon or Google. Interesting use cases that decline this problem into its practical implication, an initial interesting user evaluation that presented interesting change in the habits of people that use the system, and last but not least, a public available tool that can be used by each of us, and you are encouraged to use it and see how do you behave with respect to exposure of your personal data. Resuming all of this property in one of the sentences from an anonymous reviewer, that this is nearly everything I'm looking for in a best paper. And given the COVID rules, for this year, we will simply take the stage with the certificate to the authors in this slide form that is still respecting all the distances, even if we are, thinking about sending the certificate to the authors in real shape. Now I don't take any more time with it. I hope you will enjoy the best paper talk, and I leave the stage to Marija that will present the work. Marija Schufrin. Thank you.
Hello everyone and welcome. Thank you very much for choosing our paper as best paper for VizSec this year. My name is Marija Schufrin, and Stephen Reynolds and I will give this presentation today also on behalf of Arjan, Kuijper and Jörn Kohlhammer. We will present our paper with the title A Visualization Interface to Improve the Transparency of Collected Personal Data on the Internet. Essentially, we present our research towards an application that visualizes personal data exports from online services. And first, we want to motivate our approach.
More and more people use the internet and the many features of online services. By using them, data about users is collected continuously. Companies gather data to offer more content, improve their services, gain insight about the users, or to increase the relevance of advertisements. This enables them to create an increasingly detailed profile due to continued use. But users seem to be largely unaware of the data traces they leave behind. In the face of growing privacy concerns, we believe it is important for people to be more aware of their data, or at least have the possibility to find out more about the growing repositories that contain their personal data. Thus, strategies to increase the situational awareness of personal data stored by online services are needed. Our approach in this paper is clearly linked to the topic of privacy. Privacy in the digital space is changing rapidly due to new technologies that were created over the last few decades. Current threats to privacy are made possible by global mass surveillance, vast databases, and fast distribution networks. Legislation in various countries is slowly catching up to give people more control of their data. A recent example is the European GDPR, which regulates how personal data is handled and gives more rights to users. Among those is the right to data portability, which allows users to download a copy of all their personal data stored by online services. In this talk, we'll call it a data export. It contains any information related to that person, but the many files and formats make it difficult for casual internet users to get an overview of the data. There have been previous approaches in this area, of which we want to highlight 3 papers. Privacy Insights by B. et al. Shows a graph visualization to describe the origin and flow of a user's personal data. DataTrack by Fischer-Hübner et al. Is using different views for parts of the data, here showing an overview of the disclosed data. Both approaches address the legal requirements of the GDPR, but don't give users an overview of the contents of a data export. Finally, Visits by Todt et al. Visualizes location histories from data exports from various services. Their goal is primarily to reminisce, self-reflect on the past, and to share these with friends and family, rather than to increase privacy awareness. There are more related approaches that we analyze in our paper, however, we have not found any that provides the possibility to visualize and analyze GDPR exports by multiple services simultaneously.
Okay, so let's have a look at the design space that we have targeted with our approach. Let's start with the users. Our targeted user is the common internet user. Maybe users like you and me with more computer science background, but also friends and family with no explicit technical background. As a prerequisite, we have determined that the users must have sufficient digital skills to use online services such as Facebook, Twitter, Instagram, or Google. After all, we need to have an account with at least one of these services to provide some data for our tool. However, not all internet users are the same. There are different privacy attitudes that can be observed. Weston distinguished three categories: the unconcerned, users that are simply not concerned about organizations collecting their personal data; pragmatists, users will weigh the benefits against the intrusiveness of data collection and believes that organizations should earn their trust rather than automatically have it; and the fundamentalists, users who are distrustful of data collection by organizations and cares about privacy. Our approach is meant to support all of these user groups, even if we have different attitude toward data. Before we come to the data, let's take a look at the goals what we are targeting with our approach. So, what we want is to improve the transparency of collected personal data on the internet. In other words, we want to increase the situational awareness of the internet user for where collected personal data stored at the online services that we use. Ansley defines 3 stages of situational awareness, which we have used to define our goals. So, the first goal is to support perception. In the context of personal data, that means what the user should be able to see what data and how much data is stored where. The second goal is to support comprehension. This means the user must be enabled to understand what the perceived data elements mean. At this stage, recognizing coherences between different data elements is relevant as well. The third goal is a long-term goal, namely to support the projection. In the given context, this means an influence on the personal privacy attitude and behavior change of the user, resulting from the discoveries made in the inspected data. Based on these goals, we have derived tasks and requirements and made the design decisions for transparency this. Okay, and now let's talk about data. In this approach, we are focusing on the data stored directly at online services. Due to the GDPR, acquiring this data is comparably easy for a common internet user. The user simply can request a copy of the data as an export. However, the procedure to acquire this export differs quite a lot, whether we are looking at the response time to the request, the receive format, or the granularity of the data. With the proposed approach, we have focused on exports that come in as zip files and include machine-readable data, mostly JSON. But even these exports vary quite significantly in format, content, and structure. So, with our goal to design a tool where data from different services can be inspected and compared to each other, we need an approach to unify this data. That's why we have defined a unification scheme for pre-processing of the data exports. Essentially, we have defined 2 data formats. The file elements are elements that can be found as a single file in the export, and the data elements are further elements that can be extracted from the machine-readable files as JSON, CSV, and others. An example for a data element is a message which is part of a conversation log. Furthermore, we have defined a set of categories to which each element is assigned by the parser. The application can be extended by other services, which requires writing another parser for the data structure of the new service.
Our research resulted in the web application Transparency VIS. It allows users to insert their own data and explore it in a visual and interactive way. Users can drag and drop their zip files they received into Transparency VIS. The appropriate service is automatically detected. The data is extracted and transformed into the visualizations. The data is handled in the front end without sending any data from the client to an external server. Then, users are free to explore their data in different views. We can have a look at the views through a fictional use case. A person named Bob visits Transparency VIS and reads the instruction to learn how to request a data export from one of the supported services. After receiving his data export, he drags and drops the zip file into the drop zone. Once it is successfully loaded, he can add more data exports, but we keep that for later. First, he visits the file view, a tree map visualization that shows all files contained in his data export. Each rectangle is a single file, with the size corresponding to the relative file size. Here he can see the amount of images and videos which is stored by the service. The color of the files indicate the category. He can filter the categories on the left sidebar to find ones that might be of his interest. He then spots a relatively large message file, the big rose one. By inspecting the details in the tooltip, he learns that the file contains conversations with Alice. He then views the time view. This is a scatter plot to support the exploration of patterns and trends of the data elements. The repetitive circles of time are considered and split into two dimensions. The x-axis shows the years and months, while the y-axis shows a single day. Each circle in the visualization represents a data element, while the color indicates the category. Here Bob can first see an overview of his activities over the years. He can see that he was very active from around 2011 and has since not used the service as much. Again, he can filter by category, but he can also search for specific terms. For example, here he searches for Alice and views all the messages they have exchanged. He can view details with his mouse by hovering over the items, and he can also zoom into the visualization. Afterwards, he can view individual items in the list view. It contains all past data elements to allow users to inspect them in detail and to reflect on the personal value of the data. Here, Bob can rate the individual items based on his perceived sensitivity of them. The value above gives a summarization of the current rated sensitivity of the data. In the last example, we use just one data export. Another use case is the functionality to insert and explore multiple data exports simultaneously. Our two users, Bob and Alice, have both entered their data exports from their own Facebook and Google accounts. In this scenario, we can enable the multi-view mode in the time view. This renders 4 timelines for each export, so the users can compare them more easily. We can see Bob's data export from Google on the bottom right. It shows a lot of location data from his location history in orange, and other activity in green from his web history, both which are almost absent in Alice's data from Google on the bottom left. We can also see similarities and differences in their usage of the Facebook platform. Both Alice and Bob had a lot of activity starting from around 2011 and with recent years seeing less activity. Bob seems to use various features, while Alice primarily used to send and receive messages in pink. You can find more information on the functionality of the tool in the paper.
We have evaluated a prior version of Transparency VIS and have already used the results to improve some functionalities, whereby the focus was on the appropriateness of the tool and the perceived usability. The evaluation was conducted as an online study with 37 participants, where the participants could explore Transparency VIS with their own data. The participants were led through a fixed process by the evaluation tool without the need for an instructor. Therefore, participants could conduct the evaluation on their own, at their own pace, and in their familiar environment. This way, the usage of the tool during the evaluation was close to the natural context of an everyday situation, in line with the targeted user group. Details about the evaluation procedure and the use questionnaires can be found in the paper. Overall, we have received much positive feedback, also requests if the user can share the tool with her friends, what is really positive feedback. The system usability score of the previous version was 65.3. For the current version, we have already improved some functionalities based on the evaluation results. For example, we have added a search functionality and improved the zoom and filter functionalities. When we have used the questions proposed by Bergman et al. To determine the privacy concern group of the participants, and as you can see in the bar chart, that results in 11 fundamentalists, 17 pragmatists, and 9 unconcerned. But now let's have a look at the results with regard to our goals. So our first goal was to support the perception of data. For this aspect, it was mainly relevant whether the tool was able to make the users perceive where data. So we asked the participants directly whether the tool was appropriate to see the amount of data, the type of data, and trends and patterns. For the first two, the majority approved the appropriateness. Additionally, we asked the participants after the usage of the tool to report which types of categories we have seen, and the diagram on the right supports the estimation where the majority of participants was able to perceive the types of data. The estimation concerning the appropriateness to see trends and patterns limp a little bit behind. However, we have also asked the participants to share with us whether we have actually seen trends and patterns, and if yes, what kind of patterns. This way we wanted mainly to evaluate goal 2, namely to support comprehension. The diagram shows the distribution with regard to the user groups. And we have clustered the answers that have been mentioned and were under, for example, the user named the usage pattern with regarding to the platform. This is, for example, decreased activity on Facebook or changes from one platform to the other. Or personal events and patterns, for example, sleeping patterns, online times, holidays, birthday congratulations, or changes in job. To determine whether the tool might have had any effect on the user, we have directly asked whether the participants experienced an influence on their privacy attitude. Thereby, we also clustered the reactions. For example, many anticipated on more attentiveness for their own personal data handling and online behavior. Some intended to check and change privacy settings, maybe switch to more trustful platforms. Some other deleted their profiles. We have also used a PANAS questionnaire of Watson to inspect the emotional effect before and after using transparency this. We could observe a slight significant shift for the values scared and upset, and a marginal shift for the value determined. With one of our goals being to trigger more attention for the effect of online behavior, an increase of a slight alertness based on the insights can be seen as success. Okay, so what have we learned? So we were really happy to see that the possibility to visually explore their own personal data received a positive resonance at the users. But however, to reach a broader group of common users, the visualizations still have to be improved to meet more the needs of real non-experts in IT and visualizations. When the different formats, structures, and content of data from different online services is a big challenge, especially with regard to unify and to compare the data, and to be sure to show all elements of data. This depends mainly on the quality of the parser. And what we also have experienced is that frequent changes of the export formats, even within one service, makes it difficult to maintain the tool. For example, we had to adapt our parsers at around 2 to 3 times since we have begun to write this paper. Okay, so let's come to the conclusion. We have presented Transparency VIS, a web interface to visualize data exports from different online services. It allows users to explore the personal data from one service or to combine and compare different data sets. The proposed unification scheme allows a comparison of data between services and makes the tool extendable for further services as well. We are happy about the positive resonance of users from the user side and are motivated for further investigations and improvements. So as next step, we plan to further redesign some of the visualizations to meet the needs of real non-experts in privacy, IT, and visualization. Also, we aim to improve the feedback loop concerning the perceived sensitivity of the user. And another challenge to solve is how to cope with the differences and rapid changes of data structures of the export. In any case, feel free to try it out with your own data online. We are also happy to receive any feedback. You can find the contacts on the website of the tool or just Googling us. And thanks everybody for listening and have a nice day.
So, thank you all for the very interesting presentation and a lot of insights that are there. So let me check for questions, and I have one at the beginning. So I was particularly interested at the beginning from the fourth point that you put, so difficulty in obtaining the data related to the schema of the data, the general schema of the data that you created, okay? So what in your opinion will be the maintainability of it? So essentially capability of expanding the schema where new data are collected and eventually how to cope with the problem of frequent change in the parser with respect to the schema.
So you are asking how we could extend the schema to...
Exactly, because platform will continue to probably evolve the data they collect over there.
Okay, actually, this is really not a very easy question. On the one hand side, we hope that the GDPR will be so much involved in the organizations that maybe the structure of these exports will find a equal structure so that it will be easier to parse it. At the current point in time, the parsers which we use to parse the data have to be written manual. So you really have to check which data is in such an export for each service, and then you have to fit every attribute to the category and so on. And it would be very helpful if there, for example, would be more documentation on this data, which data exports. And from our side, so from the parser side, we really depend on what is the structure of this zip file. But yeah, we will try to improve also the automatic side of the parsers as well. Yeah.
Okay, there is a question from the audience from Elizabeth H. I read it to you. It seems that the participant attitude predicts how sensitive they are to the information they are given. Do these different user types maybe need tools with different emphasis?
Sure. Our current stage of this interface was mainly actually focused on the data side, but we used this free user group. But we use this free user group more as a whole to show for each of this user group this tool is relevant. But in further research, this would be very interesting and very important to look at each of this user group and to see really the point needs of this user group, and to increase the visualization and kind of visualization and what is shown. Sure.
Okay, I don't see other question from the audience, but I have another quick question on it. In the system that you proposed, it seems that you focused a lot on explanation. So explanation on how these data are on the platform. Can you give us, let's say, one of the ideas that I have in mind is how to relate this instead to the settings and eventually to strategy that could be suggested to user, okay? So doing a step forward, not simply looking at explaining to them, but try to grasp their desiderata and then link them to the, let's say, to the parameter. Do you think it is feasible? Do you think there is some difficulties? I make this question particularly because you said that all people abandon platform, more people change platform. This is interesting from one point of view, but it's very draconian, okay? Would be much better that they take the right stance with respect to personal data exclusion. So do you think it can be done starting from your work?
So if I got you right, we plan to use, for example, this last screen where the user can rate on their sensitivity to help the user to organize their data better concerning to what is really sensitive for them, what we maybe want do not want to have on the internet, and so on. And in such a way, for example, it could be something what you can use to go to the service, or maybe to combine it directly with the service, and so that it is synchronized directly with the service. That the data will automatically be deleted, because the most problem is that the user are simply overwhelmed with the amount of data, and if we have such a support which is partly visual and partly maybe automatic, so that we can make better decisions what we really what is okay that it's online and what we really do not want to have online. Is it something what you have asked? I'm not sure if I have answered your question.
Absolutely. A lot of possibilities. I even take one of the comments that are around, it's not a question, but about the annoying fact that today many of the websites ask you again and again to essentially accepting all the cookies by default and eventually change them by going into deep. So I was even thinking if something like your approach could be let's say extended even to this kind of sometimes let's call it a borderline practice with respect to personal data collection or cookies or whatever.
Yeah, actually our first idea and vision was to cover every data on the internet, but in fact it's not so easy, and so we have started with the GPR exports, but that would be really beneficial if one can also add the cookies to the visualization and other sources of data which are available for the user. Sure.
Okay, so I don't see any other questions. So I think that thank you for the question answering and all the author for the very good work, were very interesting and I think very impactful for potential new work on this subject. And with this, I thanks all the audience. And right now we have a pause, and we will get back at 10 a.m. or depending on the time zone. Look at the program for the next session.
We present the visualizations for the Red Sea AD simulation ensemble available on the VIS Contest 2020 website to analyze the commonalities and differences in the AD features observed across the ensemble members. Specifically, we demonstrate the applications of statistical visualization techniques in the context of volume rendering, Morse complexes, and isocontours to gain insight into the potential AD positions and their spatial uncertainty for the ensemble.
Visual data analysis of large amounts of data demanded a solution which provides users the means to enter into the dialogue with the information visualization. To understand how multimodal interaction using touch, speech, and middle hand gestures can tackle this gap, we conducted an explorative interaction elicitation study. We argue that users are highly receptive to use multimodal interaction for visual data analysis and that especially the combination of touch and speech would be promising due to their complementary nature.
We present 3 external labeling concepts that allow a user to browse through point sets without the need of zooming in and out. In the first method, labels are distributed on multiple pages. The next method arranges the labels in a single row that can be continuously slid along the bottom side of the map. In our third method, labels are distributed on stacks, which a user can independently browse through.
We propose a method palette that fully automates the coloring process of categorical data and produces discriminable results. Based on both color and data spaces, our method incorporates 3 scoring functions into a customized simulated annealing algorithm. We apply our method to different types of visualizations and compare it with the state-of-the-art palettes through a controlled user study.
We present Uplift, a system that supports casual collaborative visual analytics in the domain of smart grid technologies. We applied a co-design approach to design, implement, and evaluate Uplift with experts in energy systems and members of the Monash microgrid project. Uplift uses embedded data visualization to show energy data for each campus building.
This study proposes a taxonomy of sentiment data visualization based on visual metaphors. In order to create a taxonomy, we enhanced a group of classification criteria. And then, we classified a total of 35 papers published in the last 20 years. As a result, we presented the guidelines for researchers doing research on the sentiment visualization and visual metaphors.
Functional safety analysis is an automotive systems engineering technique that helps minimize unreasonable risks associated with automotive electronic and electrical systems. We developed a visual analysis tool, Safety Lens, to assist domain experts to perform exploratory analysis of a single project as well as comparative analysis among multiple projects.
In this study, we designed Path Visa to fully analyze the passing dynamics. Users can hover on a pattern diagram to see all the passing patterns, its characteristics, and how these patterns distributed over phases. They can further click on a pattern to see its phases, select one phase to see the passing, and inspect the prior statistics during passing.
Designed in response to the COVID-19 pandemic, the novel visualization technique we are calling GOWNS accommodates continuously incoming and increasing case data without distorting past data. Layering linear scale graphs shows both small and large numbers. This allows more detail to be seen when scrubbing through time and comparing regions by realigning the GOWNS based on case numbers.
Ensuring the usability of a dataset is often tied to data wrangling. We can use provenance to log the employed steps, but these alone will not give us meaningful insights if data quality was improved. We propose to incorporate data quality metrics into the provenance model. The enhanced provenance graph can be visualized to show the development of quality throughout the wrangling process. To find out more about the visualization design and the results of our evaluation, please join us during the live presentation and discussion session.
We propose V2V, a comprehensive pipeline for variable selection and translation for multivariate time-varying data. Our approach contains feature learning, translation graph construction, and variable selection. To demonstrate the effectiveness of our approach, we compare histogram matching, pixel to pixel, and cycloGAN to evaluate variable translation. In addition, we also compare an information-aware framework to evaluate variable selection.
Mode surfaces are the generalization of degenerate curves and neutral surfaces. In this paper, we provide novel analysis on the topological structures of mode surfaces. This allows us to not only better understand the structures in mode surfaces and their interactions with degenerate curves and neutral surfaces, but also develop an efficient algorithm to seamlessly extract mode surfaces. We apply our analysis and visualization to a number of solid mechanics data sets.
This study presents a method to explore hierarchical data by improving ROD-VIS, one of the visualization techniques for multidimensional data. The user can set options for nodes and check the data in groups or individually in the ROD-VIS. 3 subviews at the right enable the hierarchical clustering structures of selected data and allow the user to grasp the features of selected data. As a result, this system allows more detailed insight into the data while solving the node overlapping problem.
Typical e-ink displays are in black and white. With the absence of color, we explored texture encoding as an effective way to visualize data. Inspired by existing practice, we summarized black and white texture properties, which can be used to encode data. We developed a prototype of design tool that can customize black and white textures by manipulating these properties.
We present VRIA, a web-based framework for creating immersive analytics experiences in VR, built upon popular web technologies and enabling the implementation of VR experiences in a web browser, accessible on many platforms. VRIA offers a visualization creation workflow for different levels of expertise using a bespoke builder tool, a declarative grammar, and an API for extensibility. We present a series of use cases along with considerations on performance, scalability, and lessons learned. See you in our talk.
We present an exploration into co-located collaborative immersive analytics in a prototype called Fiesta, the free-roaming immersive environment to support team-based analysis. The prototype allows groups of users to visualize and explore their data in a room-scale environment, which we used in an exploratory study involving 10 groups of 3 participants. We focus on the roles which 2D surfaces have, as well as how users leverage the 3D space during both the individual and collaborative work.
Existing visualization tools for deep learning classification are mostly working on natural images with mutually exclusive classes. The classification of X-ray scattering images is more challenging since their multiple structural attributes have complex relationships. So we built an effective visualization system to study the model performance and to find questionable labels or outlier images for scientists' further improvement.
Classroom participation data disaggregated by race and gender can enable teachers to reflect on their implicit biases and consciously enforce participatory equity in their classrooms. In this work, we explore a design space for representing classroom data to enable teachers to compare contributions across students and student groups, as well as compare participation rates of the different student groups with their demographic compositions.
When NASA engineers plan a mission, they turn to space trajectory designers to chart a path that minimizes the need for popular mass. In this work, we applied a topological analysis of the circular restricted 3-body problem to space trajectory design, and demonstrate the benefit of this approach to devise compelling solutions to realistic trajectory design problems.
In our talk, we will introduce a didactic methodology for crafting interactive visualizations. This methodology uses a construction kit that describes a visualization using a set of building blocks. Our approach contains 3 successive steps that can assist students and anyone interested in crafting, ranking, and improving new visualization ideas.
Many real-world analysis environments involve multiple types of experts and analysts working together. We aim to provide new knowledge about the role of provenance in a variety of data analysis scenarios. We present the findings from interviews with data analysts from various domains. Our results demonstrate how different needs for provenance depend on different analyst roles and also helps to identify possible opportunities for advancements and new techniques for provenance support.
Kirigami is a rich, complex Japanese tradition of paper cutting. We leverage kirigami to create new physical data representation and simple interaction. This is an example which shows global warming in 5 countries. The expansion shows mean temperature in each country in 1962. The user can manipulate the model by adding measure weights, and the increased expansion shows the mean temperature in 2012.
Data journalists are a compelling group through which to study data wrangling because they frequently publish their methods to sites such as GitHub. In Table Scraps, we perform a qualitative study of their codes and computational notebooks to better understand the needs and pain points of journalists while data wrangling. From this data, we produce 2 taxonomies of computational journalism and a framework for multi-table data wrangling, and demonstrate these contributions through 2 case studies.
We conducted semi-structured interviews with 20 data viz practitioners to investigate how they understand chart junk and the factors that influence how they use it in their design work. Our findings suggest a number of themes about each topic. We highlight the personal and situated nature of how practitioners understand and make use of concepts, and argue for more practice-led research within VIS.
The blood vessel structure on the human placenta can be an important indicator in the detection of birth complications, but the segmentation of the vasculature tree remains a challenging problem. In our work, we show how MRI visualizations in immersive virtual reality can help medical practitioners to identify blood vessels without the need for a contrast agent. We present the results of a user study and lessons we learned for vasculature exploration in VR.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
We present a suggestive interface for untangling mathematical knots with complicated structures. Our interface can help users deform knots with the right sequence of mathematically legal moves. It allows one to sketch and untangle knots by proposing the right method moves. If interested, welcome to our presentation.
This work presents a detailed account of an attempt to explain tightly coupled relationships through storytelling and animation in a multi-user, informal learning environment to a public with varying prior knowledge on the domain and identifies lessons for future design. It offers qualitative empirical findings with particular emphasis